Let's practice few more problems on polynomial. Find the root of 3x minus 2. So if we take this problem, if we take this equation 3x plus 2 is equal to 0, to find the root we have to solve for x. So when 2 is taken to the other side, we get 3x is equal to minus 2. So x is equal to, when we bring the 3 down, it will come to the denominator minus 2 by 3. Okay. So minus 2 by 3 is the root of equation 3x plus 2 equal to 0. Similarly, if you have any equation which is of the type cx plus d equal to 0, then when you take d to the other side, you will get minus d. So you get cx is equal to minus d. And since this is a multiplication, when you take c to the other side, you will get it in the denominator. So this is the solution. So x is equal to minus d by c is the root of cx plus d equal to 0. Okay. Second question says, find the value of k if x minus 1 is a factor of 4x cubed plus 3x squared minus 4x plus k. So if a is a root of the equation p of x equal to 0, then x minus a is the factor of p of x. So using that idea, so if we are given that x minus 1 is a factor, we know that x minus a, if it is a factor, a is the root. Here instead of a we have 1, right? So if x minus 1 is a factor, obviously a must be a root. If a is a root, if I substitute the a in the equation, I must get 0. So in the first case, since x minus 1 is a factor and 1 is a root, in the first case I get 4 multiplied by 1 cube plus 3 multiplied by 1 squared minus 4 multiplied by 1 plus k equal to 0. Okay. So 1 cube, 1 squared, 1 are all 1. So this gives us 4 plus 3, 7 minus 4 plus k is equal to 0. This 4 and this 4 will cancel out. So you get 3 plus k equal to 0 or k equal to minus 3. Okay. So again, they have given another problem and asked us to find k if x minus 1 is a factor, right? So since again x minus 1 is a factor, if I substitute 1 in the equation, I must get equal to 0. Okay. So for the second problem also, we are getting k times 1 squared minus root 2 into 1 plus 1 is equal to 0. Okay. So if we take everything to that side, k into 1 squared is nothing but k, and you get 1 minus. So this minus will become plus, this plus 1 will become minus, so minus 1 plus root 2. So minus k is minus 1 plus root 2. So the next problem is, check whether following polynomials have given factors. So they want us to check whether x power 4 plus 3x cubed plus 3x squared plus x plus 1 has a factor x plus 1. So again, using the factor theorem, right, if x minus a is a factor of p of x, then a has to be a root of p of a, p of x equal to 0, which implies when I substitute a instead of x, it should give me 0. Okay. So they are asking whether x plus 1 is a factor of this equation. So if this is a factor, then if this is expressed, if for example in the first case, if I take x plus 1 and I want to express it as x plus a, x minus a, I'll get x minus 1. Okay. So in this case, a equal to minus 1. Okay. So if x plus 1 is a factor, then I should get p of a is equal to 0 for this. So substituting minus 1 into this, so I'll get minus 1 whole power 4 plus 3 into minus 1 cube plus 3 into minus 1 squared plus minus 1 plus 1, okay, that is equal to 1 minus 1 power 4. If you multiply minus 1 minus 1 minus 1 minus 1 4 times, all the minuses will cancel out because this is an even number here, so you'll get a 1 here, right? Similarly, minus 1 into minus 1 into minus 1 is minus 1, so here you'll get minus 3. Minus 1 squared is 1, right? Here you'll get 3. Then you have a minus 1 here, okay, plus 1 here, okay. So this minus 3 and plus 3 will cancel, this minus 1 and 1 will cancel, you will be left with 1. So since it's not equal to 0, we are saying that x plus 1 is not a factor. Hi friends, so if we want to see whether x plus 1 is a factor of x cube minus x squared minus 2 plus root 2 multiplied by x plus root 2, x plus 1 expressed as x minus a means a equal to minus 1. So we have to check for p of minus 1. So when we substitute, we'll get minus 1 cube minus of minus 1 squared minus of 2 plus root 2 into minus 1 because there is an x there plus root 2. So minus 1 cube will give us minus 1, then minus 1 squared will give us 1, but there is a negative sign there, so again a minus 1. Then this minus and minus 1 will become plus 1, that will give us just 2 plus root 2, and finally we'll have another root 2. So minus 1 and plus 2 will get cancelled, and we'll remain with 2 root 2. So it is not equal to 0. So therefore, x plus 1 is not a factor of x cube minus x squared minus 2 plus root 2x plus root 2. If we take x minus 3 and this is expressed as x minus a, which implies a equal to 3. Okay, so we must get p of a equal to 0, only that x minus 3 or x a is equal to 3, so p of 3, if we get it as 0, only then x minus 3 will be a factor. So substituting 3, we get 3 cube minus 4 multiplied by 3 squared, okay, plus 3 plus 6, okay. So 3 cube is 3 3s are 9, 9 3s are 27, okay, and 3 squared is 9, 9 4s are 36, plus 3 plus 6. So you can see that 3 plus 6 is 9, 9 plus 27 is 36, 36 minus 36, this is giving you 0. So definitely we can say that x minus 3 is a factor of x cube minus 4x squared plus x plus 6. Now, if you remember your previous videos, the trick is to find two numbers, let's call them a comma b, such that a multiplied by b is equal to 12 multiplied by 1. In this case, 12 multiplied by 1, that is equal to 12. Okay, and sum of those numbers should be the b, okay, minus 7. So if you think of it, the sum must be minus 7 and the product must be minus 12. See, 12, you have for 12, right, you can have 1 into 12, right, or you can have 2 into 6, okay, or you can have 3 into 4, okay, or you can have 12 into 1, okay. So these are all the combinations, but if you look at it, 1 plus 12 is 13, 2 plus 6 is 8, okay, only 3 plus 4 will give you 7, okay, but we want minus 7. So if we take minus 3 and minus 4, you can see that by trial and error we have found two numbers whose sum is minus 7 and whose product is 12. So we can break the middle part into two parts. So we can write this expression as 12x squared minus 3x minus 4x, which is basically minus 7x plus 1. Okay. Now if you take these two terms, we can take 3x common, right, and write it as, right, so this can be written as 4x, right, because 3 4s are 12, x into x will give you x squared, and since we have taken it common, this is minus 1. Similarly, we can take minus 1 common out and we can write it as 4x minus 1. Okay, now we can take out 4x minus common, right, and we can write this as 3x minus 1. So this is how we have been able to factorize. Okay, so whenever you have a quadratic expression, you can factorize it by finding two numbers whose product is the product of these two numbers and whose sum is this one. Okay, so that is the mathematical trick you have to remember. Again, we want two numbers such that whose product is 12 and whose sum is minus 1, right? Whose product is 3 into minus 4, that is equal to minus 12, and whose sum is, right, so if I add these two, 3 plus minus 4, I get minus 1. Okay, so the product and the sum, we have found two numbers, so we can break it according to this. So we get 3x squared minus 4x plus 3x minus 4. Okay, so here we can factorize these two first term as, if we pull out x as common, we can factorize it as 3x minus 4 plus 1 into 3x minus 4. Okay, so we can take out 3x minus 4 common, so you get 3x minus 4 into x plus 1. Let's factorize a cubic equation now. Okay, x cube plus this one, the third problem, x cube plus 13x squared plus 32 plus 20. Okay, factorize x cube plus 13x squared plus 32x plus 20. Okay, so here it's a cubic expression, it's not a quadratic expression. In quadratic expression, you have to find two numbers whose product is the product of the last two numbers, and the sum is the middle number. But here it's a cubic term. So for cubic term, you need to find the factors of 20, factors of the last term. So what are the factors? It could be 1, it could be 2, right? It could be 4 or 5, because 2 10s are 20, 4 5s are 20, 5 4s are 20, right? It could be 10 also. Okay, so these are the factors of this number. Now we want to see whether any of these are factors. So x minus any of these, okay, x minus 1, is it a factor of this? X minus 2, is it a factor of this? X minus 4, is it a factor of this? So we want to pull out a factor from here. Okay, so let's try whether to see whether x minus 1 is a factor. If x minus 1 is a factor, then p of 1 should be equal to 0, correct? According to the factor theorem. So let us try p of 1. What is p of 1? P of 1 is equal to 1 cube plus 13 into 1 squared plus 32 into 1 plus 20. Okay, so definitely this is not a factor, right? So here you can try both plus and minus, plus and minus, plus and minus, plus and minus, plus and minus. Okay, so clearly here you are getting 1 plus 13, right, plus 32 plus 20, right, which is equal to 14. 14 plus 20 is 34. 34 plus 32 is 66. How about x plus 1? Is x plus 1 a factor? If x plus 1 is a factor, then p of minus 1 should be equal to 0. Okay, let's try. So p of minus 1 is what? So minus 1 cube plus 13 into minus 1 squared plus 32 into minus 1 plus 20. Okay, so minus 1 cube, you know, is minus 1. 1 squared, minus 1 squared is 1. You'll get a 13 here. and here you'll get 32 into 1 minus 1, here get minus 32, here you'll get plus 20. Okay, so 13 minus 1 is 12, 12 plus 20 is 32, minus 32 you get 0. Okay, so definitely x plus 1 is a factor of our original equation. Okay, so now that we know x plus 1 is a factor of our original equation, what we can do is we can express this equation as factor of x plus 1 into something else. Okay, for that we can do the long division. So multiplying it by x squared, we'll get a x cube here. So x squared into 1, we'll get a x squared here. Okay, if you subtract it, you'll get 12x squared plus 32x. It will come down from here. So again we multiply by 12x. So 12x into x, you will get 12x squared plus 12x. Okay, when you subtract it, you will get 20x plus 20. So if you multiply this again, this x plus 1 by 20, 20 into x, 20x here, plus 1, 20, remainder is 0. So next step is to factorize this term. To factorize this term, now we can use the technique we are using for quadratic expressions. So this is 1 into 20. Okay, so the product of the two numbers must be 20 and their sum must be 12. Okay, so if you have 20, you can it can have factors of 1 into 20 or 2 into 10 or 4 into 5, etc., etc. But the sum only 2 into 10 will give you 12. Okay, so this can be broken up like this. Okay, so x squared plus 10x plus 2x plus 20. Okay, so that is equal to x plus 1 into, so x squared plus 10x, you can take out x common, right? X into x plus 10 plus, here you can take out 2 common, 2 into x plus 10 and close the bracket like this. Okay, this can be further simplified into, so x plus 10 can be taken out common and what remains is x plus 2. Okay, so this is how we have simplified it. We have factorized a cubic expression, 2y cube plus y squared minus 2y minus 1. So let us see if there are any, so if you take minus 1, the plus or minus 1 are the only choices for this. So you have a minus 1 here, right? So plus or minus 1 are the only factors of this. So either y minus 1 is a factor or y plus 1 is a factor. So we'll see which one is a factor. So we can try p of 1. P of 1 is nothing but 2 times 1 cube plus 1 squared minus 2 into 1 minus 1. That is equal to 1 cube is 1, so this is 2, 1 squared is 1, then you get minus 2 minus 1, that is equal to 0. Okay, so definitely y minus 1 is a factor. Okay, so since y minus 1 is a factor, let us see what is the other factor. So this equation is equal to y minus 1 multiplied by what? So to find out that, we will do a long division. So I have y minus 1 here and I have 2y cube minus plus y squared minus 2y minus 1. So if I multiply it by y squared, 2y squared, I'll get 2y cube here. So that 2y squared is also multiplied by minus 1. So I'll get minus 2y squared here. Okay, when we subtract this, the signs will change. So this will become minus, this will become plus. So I get 3y squared minus 2y. Okay, now I'll multiply it by 3y. Okay, so I'll get a 3y squared minus 3y. Again, while subtracting, this will become minus, this will become plus. So I'll get a y here and I'll get a minus 1 here, and plus 1 will give me y minus 1 with remainder 0. Okay, so this means 2y cube plus y squared minus 2y minus 1 is equal to y minus 1 multiplied by 2y squared plus 3y plus 1. Okay, so we have factorized the cubic expression to a linear expression multiplied by a quadratic expression. Now to factorize this quadratic expression, we use the same trick again. We have to find two numbers whose product is 2 and whose sum is 3. That is nothing but 2 and 1. So what we can do is, we can write this as 2y squared plus 2y plus y plus 1. Okay, that is equal to y minus 1 multiplied by, you can take out 2y common here and write it as y plus 1 plus y plus 1. Okay, so again this is y minus 1 multiplied by, you can take out y plus 1 common out of here and remaining is 2y plus 1. So these are the factors of the cubic expression. We have thoroughly studied, digested, thought about and simplified the concepts for you. So please like, share and subscribe.